Hi, this is Mark Taparaskas with Developmentor. We're going to talk about the AccessCache namespace for Windows Store apps. It lets your app remember the files and folders it was allowed to access during one execution and access those same files and folders in a future run. So the AccessCache namespace keeps two lists of storage items for you, and a storage item can be either a folder or a file. To access the lists, there's two static properties. So they're basically global variables off of this class, storage application permissions. So there's FutureAccessList and MostRecentlyUsedList. So the first thing to notice about these two is they're not exactly the same type. One's storage item access list and the other is storage item MostRecentlyUsedList. They almost offer the same interface. In fact, they both implement this interface, storage item access list. The difference between the services they offer is that the most recently used list has an item removed event that you can subscribe to, right? While the other one, the future access list doesn't have that event. Otherwise, they have exactly the same interfaces. Let me go ahead and clean up that code. Another simple difference between the two is their sizes. The future access list can store a maximum of 1,000 items in the current implementation, while the most recently used list is limited to 25. The final difference between the two is probably the most important one, and that is their ordering of their items is actually different. The future access list is in fact a list. It keeps things sort of in the same order that you add them. The most recently used list is actually a stack. So it's last in, first out. As you add items and then retrieve them, they come out in last in, first out order, which is appropriate, most people would say, for a most recently used list of files and folders. So let's do a simple example to show how to use the access cache. So here's our goal: access a file on the file system, show the contents of the file in our UI just to convince ourselves that that code is working correctly, put the file in the access cache, then shut down the app, come back later, start the app again, and use the access cache to reload the file. So the first step is to obtain a file somehow. There's a couple of ways we could do it. We could go over to our manifest and select one of these capabilities, for example, documents library, music library, pictures, or videos. And then we would be allowed to directly access the file system. Another thing we could do is instead use the file pickers. I think the file pickers are a more interesting, more appropriate example in this case, because when you show a file picker without having your app having any of the capabilities to access the user's files, then the user has to navigate and select a file. By selecting the file, the user is granting your app permission to access that file. And if you use the access cache, the cool thing is you not only get access to that file right then when the user selects it, but you also get access to it later when your app shuts down and restarts and you pull that file back out of the access cache. So I think that the file pickers and the access cache work really nicely together. So let's use file open picker to get access to one of the user's files. I have a test folder over here with 3 text files, 1, 2, and 3, that we can use for our sample data. I have a text block in my user interface with the name on it, and back in the code behind, I'm going to use a file picker to access a file, and then use the helper class file.io to read the entire content of that file and load it into my UI. When I run this, I can select one of the files, and there the contents are displayed. So our code is successfully accessing the file system. The next thing to do is add this file into one of the access cache lists. Let's use the future access list for now. To add it, we call the add method, right, on the list. And there's a couple of overloads to add. I can pass in the file. And actually, you'll notice that the parameter there is storage item. It's not file, it's not folder. You can think of storage item as a base interface in this case that both storage file and storage folder implement. So the list can store either files or folders. There's another overload that takes two parameters, the file and then anything you want as a string, metadata. And that just means anything that you and your app wants to add that would help you remember which file this is. So this is the one I'm going to use. I'm going to pass in the file, and then I'm going to pass in a string. In this case, I'll just use the file name as the metadata. And that'll look nice in our UI later if we wanted to look this up or just programmatically try to determine which file was in the list. This add method returns a string, which is a token. You can think of the token as a unique identifier that the list generates for this particular file. It's that token that you need later if you want to look up one of these files. So I'm going to run it, select 1, and now that file 1 is in our future access list. I'm going to comment out that code and just replace it with the read the file code now after shut down the app, start it up again. Again, we're using the FutureAccessList. These lists have a collection of entries inside them. If you were processing all the files in the list, you could loop through them. So each of the list has inside it an entries collection. Each entry in the list is one of these things, an access list entry, and inside each entry is the metadata that we set. In our case, that'll be the file name, and then this token, which again is an automatically generated, you can think of it as a unique ID number identifying the current file. We know our list only has one entry, so I'm going to bypass the traversal there and just hard code this to pull out the first entry. Obviously, this isn't very robust code, but for demonstration purposes, it's fine. So to access the file again, you call one of these get methods. And if you know what you have, like remember the list can hold both files and folders. So if you know what you have, you can use the strongly typed methods here, get file async or get folder async. And if you guess wrong, they'll throw an exception. So if you're not sure, you can use this one, get item async, and then you can test if item is of type and there's any enum, that's file or folder. That'll let you determine which it is, and then you could cast to the appropriate reference to access what you need. In our case, we know it's a file, so we're going to use get file async and then read the contents, load it into our UI here. When I run it, we should see the content of file 1. And there it is. Now suppose we moved this file between executions of our app. So let me come over here and move that up into the documents folder. So the file's gone from here. I didn't delete the file though, I just moved it to a different location. When I run the app, it still works. If we set a breakpoint there and run it, and look at the file in the debugger, you should see, right, so there the new path says it's in the documents folder. So behind the scenes, they did track the new location for the file. If we had deleted the file altogether, then this right here would have thrown an exception. I think it's file not found exception. This is Mark Taparaskas with Developmentor. Thank you for watching.